Welcome to the Washington Stormwater Center's video series on innovative stormwater treatment best management practices. Today's topic, copper, why it's a problem in the environment and how the Port of Seattle is removing it from runoff. Rainwater collects pollutants when it hits the ground, comes into contact with pollutants, and transports the pollutants to the nearest water body. Many of our water pollution problems are due in large part to pollutants that are washed off the land by rainwater. When small amounts of pollutants from many sources are combined, they can cause big water quality problems. One pollutant, copper, which is found in brake pads, vehicle fluids, and pesticides, can have a negative impact on salmon. Dr. Jennifer McIntyre, a Washington State University researcher, found that when copper is present in streams, it greatly affects salmon's sense of smell, which is important for their survival.
So the reason we're worried about copper is not because it kills fish necessarily, not directly. Actually, it takes quite a high concentration of copper to kill a fish, but at really low levels, copper is neurotoxic. And what this means is that anywhere where there are neurons in the fish directly exposed to water, you're going to see an impact from dissolved copper concentrations. And so the example, what I'm talking about is olfactory ability in fish, their sense of smell, and also their ability to feel motion in the water around them. When a juvenile salmon is swimming in the creek and gets attacked by a predator, it releases a substance in the skin of the fish, and that's called, well, the German word is Schreckstoff, which means scary stuff. And it's literally called that because it lets other fish know something scary has just happened here. I need to be careful because there's a predator nearby. Not only can fish not smell this substance when it's in the water if they've been exposed to copper, they also behave differently. So a fish that has not been exposed to copper, it smells that substance, it freezes down, stops moving so it doesn't draw the attention of the predator. And as a consequence, they're attacked and eaten much more often than fish that have been warned by the presence of that alarm cue.
Businesses of all sizes that have an Industrial Stormwater General Permit from the Department of Ecology are required to reduce the amount of heavy metals in their runoff, including copper. Here on the shores of Puget Sound, the Port of Seattle is working with nature to reduce the amount of copper in their runoff. Their unique approach? Oyster shells. The port is using the shells in two ways. One, by placing them directly into a catch basin that has been slightly modified for maximum retention time of the water for effective copper removal. Two, by using the shells as a final polish of treated stormwater at Seattle-Tacoma International Airport. The Seaport installation at their South Seattle maintenance yard was installed in 2010 as a way to address their copper problem.
At our marine maintenance facility, we have an Stormwater Industrial General Permit, which has a benchmark for copper of 14 parts per billion. And after sampling under our required permit, we discovered that we're exceeding that, and we started to suspect that the viaduct might actually be a source. We asked our maintenance folks to build what we call an innovative sampling structure called the guzzler. And it's simply a roof with a trough attached to it, and that allows the water to drain off the roof, collect in a trough, and then hang the sampler at the end. And we actually hung the guzzler up next to the viaduct itself and discovered that we had about 300 parts per billion of copper coming from the traffic that goes over the viaduct.
To address this issue, the port began an extensive source control and treatment program. Frequent pavement sweeping, keeping materials undercover, and retrofitting their catch basins with oyster shells was the holistic approach they decided on. The oyster shells work to filter free copper by adsorption. Adsorption is the binding of molecules or particles to a surface. Many factors influence this chemical process, including the level of copper present, along with levels of calcium or magnesium carbonate, and the acidity of the water. In the case of copper removal, the results have been promising. Using this approach has allowed the port to reduce their copper numbers by an average of greater than 70%. The idea for the use of oyster shells came from SeaTac International Airport.
Back in 2005, we discovered a few outfalls that had toxicity. So we had to look into ways to prevent that toxicity, and one of which was by adding hardness to the stormwater. So we looked at some different materials. We looked at limestone, we looked at marble, and we also looked at oyster shells. And it turns out that oyster shells, which are a local product, actually did the best job of adding hardness to the stormwater. So why is that important? Well, hardness actually reduces the bioavailability of metals in stormwater and makes it less toxic to fish and aquatic organisms. To make sure that we weren't also exporting pollutants we didn't want, we did additional testing and found that it wasn't exporting anything else, but in fact it was treating for some metals, so specifically copper and zinc, and reducing them by about 50%. So there's an added benefit of not only adding hardness, but decreasing metals. And so we've applied that here at some stormwater swales. These are bioretention swales that have a polishing component at the end using an oyster shell bed.
Maintenance is simple. About once per year, the port uses a Vactor truck to remove the shells from the catch basins. This material is disposed of as solid waste. The Port of Seattle's unique approach to stormwater management has greatly reduced their pollutant loads and made them successful stormwater stewards. Here's how you can retrofit your catch basins to accommodate the oyster shell treatment bed. These materials are readily available at your local hardware or plumbing supply store. You will need 4-inch PVC drain waste vent piping with cap, leak repair putty, 4-inch removable coupling, 4-inch drain waste vent T-fixture, threaded PVC cap for bypass events, clean, non-crushed oyster shells, and cheesecloth cut slightly larger than your catch basin grate. These instructions are for a 6-inch outlet pipe. Step 1. Grout in a 4-inch PVC drain waste vent into the 6-inch outflow pipe using a leak repair putty such as jet plug. Step 2. Install a 4-inch removable coupling for ease of removal. Step 3. Install a 4-inch PVC drain waste vent T-fixture. Step 4. Attach a 4-inch PVC drain waste vent downward with holes drilled in the cap to force all the water to the bottom of the catch basin. This will ensure stormwater has a long retention time to filter through the shells. Step 5. Attach a 4-inch PVC drain waste vent upward with a threaded cap to permit bypass. Step 6. Install the oyster shells, leaving the top cap exposed. As a final step, the Port of Seattle places cheesecloth under the grate to catch large debris. For more information on this innovative stormwater treatment BMP, contact